65 out of a sample of 400 people showed a genetic marker that would predispose them to a particular disease. Calculate the sample proportion. Well, that's p hat, and it's just going to be 65 out of 400. So 65 divided by 400 is 0.1625. What is the approximate probability distribution of p hat? Well, we know it's normally distributed. 0.1625 would be the mean, and the variance is going to be 0.1625 times 1 take away my last answer, which is 0.8375 over 400. I'm sure that's not going to be anything nice. We'll just do a quick calculation on it. So we'll multiply that by that. Just get rid of it from there. Over 400. And it's not anything nice. But we are going to probably need the standard deviation, which is the square root of that. And so let's just drag that in there. And our standard deviation is 0.018445. Calculate the probability that the sample proportion in another sample of size 400 drawn from the same population would be less than 0.15. So 0.1625 is our current estimate of P. And all we're after here, this is 0.15 there, is this probability. So it's just a normal CDF. So we're going to go interactive, distribution, continuous, normal CDF. Lower, well, we could make that negative infinity or some small number. And the upper is 0.15. Our sigma, we just wrote that down, 0.018445. And the mean is 0.1625. And that is the probability that p hat is less than 0.15 is 0.2490. Find the 95% confidence interval for the sample. Well, since we're on main screen and we've already got a lot of the stuff that we need, why not let's just do it here. So 0.1625 take away. Now the z-score that we want, we can get from inverse norm. Go for center, 0.95 is 1.96. So this will be 1.96 times our 0.018445. And then we'll want the 0.1625 plus 1.96 times 0.018445. And let's see what that gives us. So 0.1625 take away my z-score times standard deviation. 0.126, and we want the same thing but with a plus in the middle. .1987. Now we could have gone to the E activity to get that. So confidence interval for proportion. Now, what were we told at the beginning of the question? There were, out of the 400, 65. So 65 out of 400, 95% confidence, 0.1263, 0.1987, there it is. Assuming the value of p hat to be correct, so 0.1625, find the sample size required to have a 99% confidence interval with a width of 0.02. So E is 0.02 and 99% confident. So we can go to here, z-score for CI, and we want 99%. We want the z-score. Okay, that's saved in there. Sample n for confidence. We've got the correct value there, 0.1625 in P. And the margin of error is actually 0.01. It's saying the confidence interval has a width of 0.02, which means that E is 0.01. Remember that the margin of error is just half of the interval. So that one is going to be 0.01. And what n does it require? 9,030.